Good evening, everyone. On time, on the dot, 7 o'clock. We made it. You know, we're over the hill now. We're past the halfway point and we're killing it. Still on time every day. What's up, Sharky? What's up, Greatest Rob? How you doing, Sandpaper? M. Gene, good to see you. Dusk, thanks for hosting. I'm tired. I'm gonna be honest with you guys. I woke up. I stayed up late. Doing a couple of things. First, if you were on last night, one of the things that we're going to do is for people who don't want to watch it on YouTube, who want actual access to the videos, I'm going to put them on videos.mastermind.io so that you can download them probably immediately. This will probably be a fully automated process. I actually spent a surprising amount of time. I was just going to make a bucket and make a little page that you can just go click on, but I'm actually going to add it to the Mastermind.io website. So I dove into that last night thinking I'd get it done. I'm close, super close. Just trying to tie it into, I had to learn some stuff about Hugo templating since my site is a Hugo site. But keep an eye out for that. I'll try to get that done. But then I was playing some games with some friends. And then I had to wake up early because we had to take my wife's car to the shop to get tires and all this other stuff. But I forgot that the time they gave me was 7 a.m. and I completely was not thinking. So I'm operating off of just a sliver of sleep, but I'm good. I'm okay. I promise you I'm okay. I have my cup of Joe with the hey Mrs. Cup. This is what was available. This is what was in the cabinet. And you know, any cup will do. So this is, you know, my one cup of coffee for the day. I'm trying to keep it to one cup. Sleep was that exactly. What is sleep? We don't know. None of us know over here. We're watching Practice Wednesday stuff tonight. I'm gonna catch up. Yeah, so that's fair, Greatest Rob. And that's why tonight we're gonna keep it relatively chill. Tonight we're gonna be talking about functional programming, and object-oriented programming is a tough concept. I do think when you're entering these things, especially after just seeing object-oriented programming for the first time, I think this paradigm of functional programming will be a little bit it'll be a little bit tough. It's gonna be a little odd at first. It's gonna be, you know, you're gonna have to think through. It's gonna be a bit of a cognitive load, but it's gonna be good. We're gonna keep it chill again, just like how we've been doing some of the other things for some of these tougher concepts in the beginning, just to make sure we go through them cleanly. I found some good guides to kind of run through and that we can just kind of dive deeper on together, that I think will be better than me trying to make up examples and things like that, especially for this topic tonight. And again, I'm not scaring you. It's not that crazy of a concept. It is a concept that is tough to do well. It takes a little bit of time to develop the skills to program, to be able to think in a functional way, but it provides its nice thing. So let's pull those things up. Also, my talk today felt like it went pretty well. I need to go back and watch it. I rambled a bit at the end. You know, that was my first official conference talk. Even though I've done a lot of things at conferences, I participated in a lot of things at conferences. That was my first official conference talk. So that went pretty well. I was happy about it. I was really happy about it. I'm excited to do more. I'm excited about the one, like I said, I'm doing one with the Live Coders crew. They're doing an all-day conference here on Twitch on the 20th, I think. And I got a little 25-minute slot there, which would be nice. And that one's gonna be fun. I've done some, you know, I'm building out a pretty fun talk. So I think it'll be pretty dope. Yeah, it is on YouTube. They're still live streaming. Like, the conference is actually still going on. But I can send the link to where it is. It'll remain up, and I'll let you know what time it was at, so you can go to it if you want to check it out. It was just about DevOps and civic tech. And how the paradigms of DevOps can be used also to solve problems when you're talking about civic tech. I appreciate that. I definitely do appreciate that, YGBSM. Thank you. Yeah, I definitely need to. I also didn't have a really as much time as I wanted to prepare for it. So I wanted to leave the end a little more open-ended. I think next time I will still leave it open-ended, but I think I'll add a little bit structure to, so I know I can stay on track with the story that I'm trying to tell, but I'll figure it out. But it felt good. I felt comfortable. I think it was a good safe space to kind of hop out there and do it. But it felt just like streaming. So I really wasn't uncomfortable or anything. So it was cool. All right, let's hop into the classroom today and let's see what we have here. So let's get into the Academy view, head over to deCoded, classwork, and just to let you all know, I'm hoping that you've put in a little bit of time this week in your 100 days of code. I have put in time, and I've actually made some interesting progress. So I do count what I did last night as a bit of code. I spent, like I said, I spent a solid hour and a half to 2 hours looking into trying to understand the way that Hugo does some of its short codes and things that it has in there. It was really weird. It was throwing me off. But I think I figured it out. Now I just have to hook up. I've got to do some like things so that the make sure I'm uploading the files with the right properties. They're big files, so I just need to enable a script, do multi-part upload and give it the right permissions and stuff. Do all the little AWS stuff because I want to automate it. I really don't want to. I basically want, as soon as the stream is done, I have a script watching a folder basically, and as soon as the file's done, it'll kick off the upload job there. So trying to make my life as easy as possible. But tonight we're going to be looking at 2 links. So there are no slides tonight. There are slides tonight. They're not my slides. And we're using these slides because one of them is linked to a talk that was done back in 2016. And I'll share this with you, and it's really, really good, really good. And I think for something like this, we're not going to go through the entire slide deck tonight because there's a bunch of concepts in here we're not going to cover. We're going to go over kind of the basic things. It's really good slide deck for that. And then there's this functional programming in Python particularly article that's really good as well, because it shows some specific examples of some of the things that we're going to try to do. So we're going to pull those and we're going to practice using those. We're going to extend those and talk about the concepts. Again, the goal for functional programming right now is not even for you to be programming anything functionally right now. It's to introduce you to it, for you to know that this is a thing, for you to kind of start to understand the different paradigms of coding that you can kind of keep in the back of your mind as you're learning things. Right now, you should probably be just worried about, again, brute forcing it, make it run, getting it to work in any way that you can, using the tools that you have available to you. But as you start to get better with them, you can start looking into things like this. And I think it'll be pretty cool. There's some functional programming with Haskell. Yeah. So I've been interested in diving into a like almost purely functional language like Haskell, just kind of see. I've never used like a purely functional language like that. I think it's pretty interesting. Maybe I'll start with Lisp, since you can do a little bit more, you can do some of the procedural stuff and some of the imperative programming still if I need to, even though I do have a functional programming after the first like jolt, it does in fact make sense to me, and it makes the benefits it provides are pretty high. I really do like it. So let's get started. We'll see if we can get some time back tonight. Again, focus on the concepts tonight. Some people are a lot farther than others. There are a lot of you who maybe understand all this stuff and you've kind of dove in before already, and you're looking to kind of sharpen your skills a little bit. There will be some stuff in here for that, but most of it's going to be catering to people who just are learning how to code. And I don't want to give people too much here, like especially when we get into functions as being first-class citizens and like, well, once you get in there, that's what really blows people's minds. I think we'll understand the kind of first couple course concepts, but it can get a little confusing because it's a different paradigm than kind of how we've been doing things already. So let's talk about it. We're not going to go straight through these slides. So this was given at a talk at a JavaScript conference by a woman named Anjana, and you can find her here. She's very active on social media, has a pretty large following, and it is a great video. I will share. Actually, let's grab it right now. Let me put it in the Google Classroom because it's excellent. And what it'll do is it'll be great for you to go through this because it will allow you to dive deeper on some of the concepts we're not going to be able to cover tonight. If you want to get there a little bit early, Jana functional. But it's really good. Copy. Let's put this in here. Search, embed it. Let's go. Functional programming talk. Again, it's not too long. I find it to be it's good stuff. There's some stuff in here, especially, and I'll tell you what to focus on. We'll hit it a bit. But we're probably well, I think they're in the slide deck, so maybe we'll go over some of it. But learning functional programming with JS tonight, we're all about conjunction, junction. What's your capital function? What's your function? Capital FUNCTION. Hope I have some other Schoolhouse Rock fans out there. Again, that statement means almost nothing, but it's got the word function in it. And it sounds like a great tagline for tonight, so that's who we are going with. But we're gonna be learning a little bit of functional programming. This is with JavaScript. The examples are gonna be given in JavaScript. We're gonna take those examples down immediately, and we're gonna hop right into an editor, and we are gonna see how some of this stuff works, and we're gonna learn some of these main concepts. And this is, if anyone has toenail fungus, this is a pretty gross picture. Or if anyone wants to switch to Xfinity Mobile. Maybe sometimes there are good, ad blockers can be good, but yeah. Let's see. Functional programming is a paradigm of programming, just like we talked about object-oriented programming being a programming paradigm centered around objects and managing and modifying and using objects to get your desired output. Functional programming is the same way, but it's centered around functions. And yes, those are the functions that about. The functions that we've learned already, write a function definition. So def, my function, maybe taking a parameter or 2 or 3 or 4, some code underneath. It is centered around that concept. But it is a different paradigm than what we've learned before. So some of the languages here is going to go into some languages here. There are languages out there that are purely functional, and you might say, oh, well, what makes that different from another function? I think we'll be able to cover those things as we go along. But some of them, people have already said in the chat, are Haskell. Lisp is a language that's functional as well. It's not purely functional, but it's functional. And a lot of languages allow you to operate in a functional paradigm. The same way we talked about all languages aren't object oriented yesterday. Same thing with functional. Some languages allow you to operate better functionally than others. There are concepts and paradigms of functional programming where some languages have tools and things built around this to help you work through it. Other languages like JavaScript will allow you to, there are packages and things that are written to allow you to get some of that goodness that you want in here if you want to operate in a functional manner. But the concepts, the thing I like about learning functional programming, at least, is the concepts aren't crazy. There's really only these 3 main concepts for the most part. There are these 3 main concepts. To really master them gets a little bit tough, but to understand them, I think, is relatively easy. And so we can kind of focus on, it's like, all right, cool. I can learn the 3 big things about this, and I can grasp those pretty well. But then I can use those, like once I get that, then I can use those and go learn and figure out how how this stuff actually works. But the concepts are pretty simple. So the first one is pure functions. And so this is I love the word pure here. It's the perfect word, pure functions. And it starts off saying it does not have side effects. And so this sucks sometimes because it's really hard to understand what side effects means. And I think you'll understand that after we go through some of the other things. With pure functions, they don't have side effects, but they do not change the state of the program. And again, this also doesn't help until you kind of see some things in action. Pure functions are basically there to do exactly what they're supposed to do. They're designed in a way to perform an action without doing anything else besides performing that action. Without input from outside somewhere in the application, it's designed to do one exact thing, and it just does that thing. And so because of that, given the same input, a function will always produce the same output no matter what. You might say, hey, I feel like the functions that we've written so far do exactly that. They might, because our programs have been relatively pretty small and haven't really had to manage state. So we'll dive into that a little more, but right now, pure function just means kind of in the purest form, the function does exactly all the function does is what it's supposed to do, and that the input, the same input will always deliver the same output. So that makes it pure. And again, it's a nuanced concept, and it's easier to understand when you actually see it. In Python, it's using Lambda functions, functional programming. Yes, Lambda functions are used. Yes, Lambda functions are used to program functionally. You can do it without Lambda functions. They help a lot for depending on how complex your program is, and it helps syntactically and kind of just a little bit easier. But you can program in Python functionally without doing Lambda functions, and we're probably doing one example with Lambda functions to kind of just get you introduced, just get your feet wet. But again, I think it's a big confusing factor thrown in with the rest of these things. What's up, Calendine 23? What's up, James Harris? Good to have you. Box Puns, good to have you. All right. Again, pure functions. We're gonna do an actual example. I think this has an example in it, but immutability. We've talked about mutability and immutability before. Where do we do that at? Data types is where we did that at. We were discussing data types, and we learned about data structures, and we learned about the data structures that we learned are also data types. Most of the ones that we learned, but we learned that there are some immutable data types inside of Python, like tuples. So we learned about lists, which are ordered list of objects, but those things can be changed. A list is mutable, but a tuple, with those parentheses, is not mutable. Once it's there, and it cannot be changed. And so immutability is a big deal in functional programming. The whole goal of functional programming is to not have to worry about the state of that program or worry about accidentally modifying the state of that program. And if you do, knowing where it is because you've done certain things. So the concept of immutability says, hey, when I create a variable, although variables are designed to be changed, the word means that they can be changed. In functional programming, we don't change them. We don't change those variables. We don't change those values. What we do instead is we either copy it to another variable, or when we need to modify it, we create a new variable or a new item at that. We don't transform the actual thing, and so we'll see that as well. So that's immutability here. Once something is kind of there and created, we shouldn't mess with it. I wouldn't say we can't, but in proper functional programming, you don't change those things. And so it's an interesting concept. So data cannot be changed after it's created. It says that's the concept of immutability. For example, create a list with 3 items and store in the variables my list. If my list is immutable, you wouldn't be able to change the individual items. So you just literally giving you an example that states immutability. So we'll see that with tuples in a second. And the last one is higher order functions. And we're going to talk about all these again as we go through things tonight. We'll talk about them some more, but I want to get you introduced to the three concepts right up front. So higher order functions, what this means is really that functions in functional programming are what you would refer to as first class citizens. So functions kind of operate, you can use them in the same ways that you are operating with the rest of the variables and things that you're used to using. And so that means that functions can be passed in as parameters for other functions. So like when you say a function, function print address, and maybe the address takes in house number and street name. The same way you have that, you can actually pass functions in as parameters. Instead of a variable that's a placeholder, you can pass in a function as a placeholder, a whole entire other piece of code that does amazing things. You can do that. And so we'll see what that looks like. But it also means you can return functions from functions. So the same way, we go through a thing and maybe the function is to add up some numbers, or maybe the function is to do print the fizzbuzz function that we wrote to print out to 100 and do some stuff, and then at the end you return a number. Remember, functions only run when called. And then things that all the data in there that has been modified, all that stuff, it can't be used out of the scope of that function unless you return it. In functional programming, you can actually return entire functions from another function. And so we'll see that. And this is where it gets very confusing. The higher order functions piece of it is, I think, where it gets tough and why it looks so crazy when you look at a program that's written functionally. It can get pretty wild. Also, another big piece of functional programming is recursion. And we talked about recursion a little bit in one of the classes before this. We are not going to dive into recursion, but it's another reason why it looks crazy, and why if you go just Google like some functional programming examples, they're actually very confusing to look at, because a lot of times you're going to be using recursion in those things to get to the end goal. But the whole goal of functional programming is to use functions, is to separate out data. So the data, the variables and their values and things, what you're doing is you're separating that out from the actual functionality of the code. So when you're thinking about functional programming, we want to be thinking about what things need to happen, what task needs to happen, and only focusing on that task that needs to happen to do what we want to do. And we want to use functions to get all the way there. Maybe we need to create some pure function stuff first to kind of see how that's done, but it's very interesting. And there's some great examples below this. But let's take a look really quick at the slides here, because I think she covers the same things very well. So it's a coding style. Functional programming is a mindset. I really liked this slide because it's certainly a way of solving a problem. It's a mindset for how to solve a problem. It's very interesting. What is a functional programming? It is a sexy buzzwordy trend. I think this was true in 2016. I still think it's obviously a buzzword. I no longer think it's trendy. I think it's become a little more part of the a more accessible, consistent piece of the programming experience, to be honest. I think more and more things are done functionally. There are actual languages that allow for this, that are specific for this. I don't think it's necessarily a trendy word anymore, but I do think it's a sexy buzzword, as are most technical terms. We're going to skip why functional JavaScript. I did think this part was interesting because JavaScript is an object-oriented language. It can get pretty tricky inside of JavaScript. But again, also, for simple things, it's pretty simple. Now, you might say, hey, why would I want to use this thing? If you're saying that it might be a little bit tough and it might be a little weird of a paradigm, and when I look at it, I might be a little bit confused, why would you want to use it? These are the reasons right here. These are really, really good reasons. So it is absolutely safer and easier to debug and maintain. Well, at least I don't want to say absolutely, but for me and in theory, for the way that programs go wrong, it's easier and safer to debug and maintain because you're not worried about state. State is one of the hardest things to debug and to account for when you are programming. Understanding what, like the where, like, you know, maybe your program ends up running a function 12 times and you know, maybe it's modifying some type of variable on the system, you know, lots of times, and maybe you're seeing something wrong, but you don't know in which iteration that's happening. It's really hard to track down, like to follow, you know, these changeable things throughout the life cycle of your program. And so because we are we're using immutability and we are not changing values, when things go wrong, we know exactly which state they went wrong in and where they went wrong in. I shouldn't use the word state there, to be honest. But yeah, it's just a little bit safer. It's a little bit easier it's a lot easier to debug actually and to maintain, but I do think it's a little bit more of a mental hurdle right up front to kind of think through. But yeah, just this is probably the biggest reason. Once you get good at it, once people get comfortable at it, I know a lot of people who swear by functional programming because of the kind of ease of debugging and maintaining and knowing exactly what's going on in the program. Yeah, it is. I agree with the statement that it's easier to debug. Okay, and so what we'll do is let's take a look. We'll stop there, ask any questions you have about what we've gone over so far, and let's start seeing some examples. Let's start getting our hands on some code so we can kind of feel what this means. Let's start to feel a pure function. Let's start to feel, you know, and see what it means for the data in there, or for the things inside of the application to be immutable, as well as for first order functions. I mean, it's going to be confusing. Higher order, sorry, I don't know why I called it first order because I just said the word first. Higher order functions, yeah, it's going to be it'll be a little bit interesting. So any questions about that so far? Java considered functional? No. Java, you can do object oriented things, but no, it is not considered to be a functional language. Java is usually considered to be an OO language, isn't it? Pretty sure it's usually considered in the OOs, but it's not a class-based object-oriented language. Okay, yeah, but yeah, we can go through kind of a list. We can find a list of kind of what some of the most common languages are for this. Again, I from what I've seen, again, Haskell and Lisp are for sure the languages that when people usually are talking about functional programming, people talk about those a lot. Again, you can absolutely do it in Python, you can do it in JavaScript. A lot of languages provide paradigms for you to do it, but some languages aren't fully supported or as supported as others, mostly due to the immutability of those data types. And we may not cover it, but I highly recommend watching this because she does go over the issues with having immutable, you know, these immutable types, these immutable things. There are caveats to that. You know, everything in programming, everything in coding is a trade-off. Everything is a trade-off. Every decision is a trade-off, and there's always there's almost always a downside. So there are downsides to doing things this way, for sure. And there are, you know, there are things that have been accounted for to make, you know, little ease of life things easier, but you just got to figure out if it's something that works for you. Major trait of functional programming is that it's missing less than native language support. Function currying. That's yeah. Yes, we are going to be talking about currying and hoisting and all that as well. Functional. What's up, Uncle Bill? How you doing? Good day, Colonel Panic. Also, yes, thank you for the host, Uncle Bill. Okay, don't panic. I like it. Don't panic, Colonel Panic. But good evening. All is well. I hope all is well with you as well. So, okay, let's do it. And let's check out her example first. I actually don't remember what her example is. I like this slide. I really love this slide. I think I've touched on this before, and maybe this should have been a little precursor to you to kind of see why I feel like why it makes more sense to me, why functional programming makes more sense to me. Like I said, almost everything you're gonna be doing when you're programming is going to be getting some input or taking in some input, processing it in some way, and delivering some output. So like this is what programming is 98% of the time. And so to do this, functionally, you must do everything with functions. And again, it's more than just that. It's much more than just that. But let's see what her examples are, and let's see if we can make them. Let's see if we can break them down and play with them, and see if we can understand what's happening. So she has a non-functional piece of code here, and this is in JavaScript. But hopefully, because we've been touching a couple of different languages, even though we've been focusing on Python, hopefully your eyes are starting to kind of see and kind of understand what's happening here. So there's a variable. We're setting up a variable just like if we did in Python, if we did name equals Anjana. So variable name equals Anjana. So we set up one variable. The variable is called name, and it's equal to the string Anjana. Then we made another variable, which is greeting, and it's equal to the string hi, kinda, comma, I'm. And then this is just like the print statement. This is just getting the information out this is displaying output, and they're concatenating greeting plus name. They're adding two strings together end to end and to print out this. And so let's get this into an editor really quick. And let's see how it's modified to be functionally after this. I think she does have a slide on that, but again, we want to play around with this. We want to make sure we understand as well. Okay. Oh yeah, since it's just JS. Yeah, I feel like that's a little more confusing, to be honest. And I don't like the way the scaling happens in here, but so just so everyone knows, we don't cover a lot of JavaScript here. But what you can do is JavaScript, like I said, is the language of the web. Your web browser runs a JavaScript engine in it. And so you can actually go into your developer tools and go into the console, and you can actually type in, JavaScript right here. But we don't do, yeah. You could do something like that, if I want to do a hello world, and I could just run it, and it does in fact run. But I don't think that's a really good experience. Yeah, it's easily available, but I wouldn't worry about that right now. Either head over to REPL.it or open yourself up a file in VS Code or wherever your text editor is. Let me make a folder for this. I'm gonna stop looking at this keyboard. Let's see. Oh, it's just so different. The stuff is like, it's so close. Ugh. But it's just so different at the same time. Then make a deCoded folder. deCoded class examples. Okay. I'm gonna make okay, there we go. I had to actually feel where the little notches were on the keyboard. Okay, they're functional. CD functional. And we're gonna make a file called, let's call this first.js. Because it's our first one, we can call it whatever you'd like. But again, open up a VS Code, open it up in whatever you want. But just make a file, call it whatever you want, so that we can start editing. And what do they do? This is JavaScript. So they use var, so this is probably a bit old. We'll do exactly what they did and not use let. Oh no. var, name, and you can put in your own name if you want. There we go. Var name is equals Aaron, and then var, what was it? Greeting, greeting equals hi, comma, I'm. I will say I'm better at using, I'm better at hitting characters on this laptop keyboard than I am on the 60%. And that's mostly because there's dedicated keys for them on here. And then what else did she have? I had console.log greeting plus name. So let's look at that. Console.log, and we did greeting plus name. Okay, so we have exactly what she has here. And again, all this is going to do is it's going to make two variables, our name and a greeting, and it's going to stick them together. Yeah, this is not obviously, it's already obviously not functional because it's not, there's no function in it, first off. But excuse me, it is non-functional code. I did not mean to do that. And so if I run this node first.js, it will say, hi, I'm Aaron. I think we expected that. That's so far, no new concepts. Great. Let's see what it looks like when you do it functionally. And there's some key caveats here that you're probably going to miss when you first do this. So they now have a function. And so they have the keyword here to create a function definition. The function name is greet. It takes in one argument, it takes in a name, and it returns this. Return, hi, I'm name. And then when you call it, you've got to call it with a name. So we'll take this, we'll write it really quick, and let's talk about this real fast. And so I'll leave, let's see, is it Control V Shift, oh wait, no, wait, I can do this. Hold on. It is Control V, down, Shift I / escape. There we go. I'm really trying to get my Vim game up, but you know, I'm not the best at this. So let's delete this. Let's go function greet. All right, I'm just gonna look at it. Greet, it takes a name, and in here, what did they, all they did was they returned hi, I'm name. Makes sense. Okay, so this is how they did it functionally, and instead they called it like this, greet, and they called in, I'm gonna call Aaron here. Okay, so these are the same, this is the same code, or this code will achieve the same output. Setting up a variable called Aaron, setting up a variable called greeting, and then using a console.log to combine those things, to concatenate those things and print them out to the screen. But so interestingly enough, this is not going to do what it says it's going to do from the slide, but let's run it anyway. All right, so nothing spits out to the screen. Why does nothing spit out to the screen? Because there's no print here. There's no console.log. We're not telling it to do anything. But that console.log, notice how we're returning this line. We're not printing it out. Even doing things like print, that's not a part of what this function is supposed to do. And that's why functionally, you usually don't stick that stuff in here. You usually wouldn't stick any type of print functions, any type of display functions inside a function like this. But this is a pure function. Why is it a pure function? It's a pure function because no matter what you do, every single time, it will, no matter what input you put in, it will always return the same thing every single time. But it also is not taking information from anywhere else. Like this would not be a pure function. If I did this and I enabled this line and I said, hey, name, I'm gonna set a variable called name, and I'm gonna print this, I'm gonna do this function here. Function greet equals hi, I'm name. This is not a pure function. And why? And so it'll still work. It will still, if I actually print it out, it would work, but I didn't give it a print statement. Like if I did a console.log here, I did that. This is not a pure function. It works, but it's not a pure function. Why is it not a pure function? Because it's taking out the function itself is not self-contained. That function itself it's dependent upon this global variable we have, this variable that's in the global scope called name, and that thing can change. That variable can change throughout our program. This introduces a paradigm of state, and you know, this may not always return the same thing if the variable name changes. But when it was the other way, when this was commented out and we took in the information that was needed to be processed here, oops. When we did it this way and we passed it in down here, this is functional. Again, no matter what, this will always return the same input, will always return the same output. No matter what name I put in, no matter what thing that I put in, it will always do exactly what it was meant to do. It'll always do the purest of things with your code. And so that's your kind of first intro into the pure functions, into the functional programming here. Logging to the console is a side effect. Exactly. It should be handled with care. Yes, that is very true. 100% true. These are things that are extra. These are side effects. These are things you need to watch out for. And again, it's hard to figure out. It takes time to figure out what things you are common in your coding paradigm already that you now can't do. I don't want to say can't do, but is not advisable in functional programming. But again, that function should do only what it's supposed to do. So the greeting function should, you know, the ethos of it, the core of the greet function should just append a greeting onto a name, prepend a greeting onto a name, and it does that. And no matter what we pass in for name, there's nothing else that can change this. No matter our input, whatever our input can always change, but that, you know, the input will always provide a consistent output no matter what we do. So it can be very confusing. Real difference between function name and function equals. Oh, function name equals. Oh, great. Oh, that's a good question, Mr. Anderson. I like that. There's a difference. So there's a difference between arrows. The difference between doing it the first way you have it, which is the normal function declaration, and well, no, there is not. There may be some underlying things, but you can operate with them, as far as I know, the same way. But JavaScript might be weird, but you can operate with them in the same way. But usually the second paradigm you have there is done kind of with arrow functions, and that does work a little bit different. Allows you to pass the name around like a variable and treat the function as a first class citizen. You can also, I think by default, you can, and this might be because JavaScript is built to, every time they update it, they allow you to do more that you want to, like, they just allow you to do everything. I think you can pass around, I'm pretty sure you can still pass around these functions like first class citizens, no matter what, in JavaScript. Pretty sure, not 100% sure, but pretty sure. Yeah, yep. Yeah, it looks like somebody threw that in there. Thank you. Yes. I will do my best to cover decorators, generators, and yields sometime tonight. I will try that. I'll definitely try to throw these in here because that's not something that we specifically cover, and they are good to know. And I do think that I do think they fit in during this time. So we'll see where we can fit them in. Okay, so that's just the basic functionality of the most basic of things that you can do with a functional program. And so I like that example. Let's see what example we have in Python over here in the walkthrough. I want to see where they start when he's talking about pure functions. Let's take this and let's see how this differs and see if we can kind of understand what they're talking about. So if you'd like functions to be pure, then do not change the values of the input or any data that exists outside of the function scope. And that might be the key word there. So don't change the input or any value that exists outside of the scope of that function. This makes the function we write much easier to test. So that's true. We learned a little bit about automated tests when we were learning about how to use, what were we trying to eat? We were learning how to use exorcism, and we learned a little bit about tests. We haven't dove far in at all about that. We will be going over test-driven development, understanding how to write tests and understanding what tests are for, but we aren't there yet. But this does make it easier to test, as it does not change the state of any variable. We are guaranteed to get the same output every time we run the function with the same input, and that is what we like. So we have here, let's create a pure function to multiply numbers by 2. Okay, I like this. I like this example. And so maybe before we even look at this, maybe let's try to create a function in Python to multiply. Oh, this is let's take this, and then maybe we'll try to write it in the way that you would probably write it if it wasn't a functional, and maybe we'll find that this is the best way for this. Original list of numbers. Okay, let's check this out. So I'm gonna copy this into a brand new file. So this was our JavaScript file. I'm gonna go into a brand new one. Let's put this down a little bit. There we go. I'm gonna vim a pure.py for our first pure function. I'm gonna paste this in right here. And so let's take a look at it. Let's see what it's doing. We'll see if we can understand what it's doing and mess around with it. Okay. It has a function definition here. It's a definition. It's a function called multiply to pure. So pretty descriptive with the underscores here, and is a function that takes in one parameter, which is numbers. But we don't know what that is, but no big deal. It takes in numbers, and so we can deduce maybe that's a collection of numbers. And so the first thing they do on this line, and maybe we can put a little thing here for what's actually happening, creating an empty list. So it's setting up a variable. It's setting up a variable here called new numbers, and it's setting it equal to the empty value for a list. And so it's creating an empty list here called new numbers. And that's what this line right here is doing. Now, when we get down here, let's put a little space in here so we can see. We get down here, we see the word for, and we know that that is the keyword to start a loop, to define is to instantiate a loop. And it says for in number. So this is a for each loop. That's basically saying for everything, for each item in numbers, in the numbers collection, do this thing right here, and then return new numbers. So it's gonna do new numbers dot append. And so let's put our stuff here so we can practice looking at code and breaking it down. So begin for each loop to iterate through items in the numbers list. All right, that's what that line starts. And then this line right here, it says new numbers dot append, and it's got n times 2. So we learned about append. We did learn about append. It was a little while ago. But that is a that's a method, and we learned about object-oriented programming. This is, so I don't want to confuse you. This is not object-oriented programming, but new numbers in JavaScript, like these things are objects. This is JavaScript. This is Python. These things are objects, and we can apply this method to this new numbers object. And so append, what does append do? Append adds an element to a list. And so what it's going to do is, remember we set up this empty list up here called new numbers. It's going to say new numbers dot append. So it's going to add on n times 2. So we're doing a little math there. And so n is going to be whichever item in this list that is on currently in this loop is going to be that thing times 2, and it's going to stick it into the new numbers list, and then it's going to return that list. Okay, so multiply current item in list by 2, and then add number to new numbers list. Okay, and then the last thing it does is it returns the new numbers list. So once the entire for loop is finished, it's going to run that entire for loop, and once it's done, it's going to return the entire new numbers list. So now let's take a look at what they have down here. So they set up original numbers is equal to this list: 1, 3, 5, and 10. Then they have another variable that's up here called change numbers, and it is equal to multiply to pure, which is the name of this function. So they're calling this function, but they're passing in the original numbers. They're passing them in. All right. And then they're printing them both out. So we'll print them both out in a second. They're printing out original numbers, and then they're printing out change numbers. And so let's run this. Python. Okay, and so we get 1, 3, 5, and 10. That was the original numbers that were passed in. And the numbers that we get back are 2, 6, 10, and 20. So these are those numbers doubled. They're multiplied by 2. But look at how it was done. Look how we didn't do anything to original numbers. We did set up original numbers, but to get we printed out original numbers here, but to get the updated numbers to run this script against it, we assigned those things rather than having a function that goes through and updates these things. We assign that to a brand new thing. We assigned it to a brand new thing, and we passed in the original set of numbers, and now we have a whole new piece of data that we can work with that we want to use. And so what something like this probably would have looked like if you didn't do it like this would probably be something more like def multiply by 2, not pure. And I hope this comes out right. I'm not thinking about I'm not pre-thinking about this. I'm just gonna write real quick. And you might say, all right, if you were gonna do it non-functionally, that means that things are not immutable, and it's probably fine for you to go ahead and resave the things to the original number. So you might say something like for I let's see, I'm trying to think of the most raw way that I would do it. Not the most raw way. I'm trying to think that if I was really trying to solve something like this for the first time, and I wanted to, multiply everything in a list by 2, how might I do it? And so I might say for I in range numbers, maybe I would do something like at first we need to do the new let's do the new numbers thing. No, we don't even need to do new numbers thing. We can do prime range numbers. No, that's going to the way I was going to do that was going to put it in an infinite loop. We probably would loop through, replace the item, like something like this, something like numbers I is now equal to numbers I times 2, or something like that. Something like this. You would basically go through and you would set the value, because you can change an item in a list. You can actually change an item in a list by referencing, its space, if you wanted to. You probably do something like that, and you wouldn't actually need to return anything. And we can check and see if that was true. But what this would end up doing is this would end up changing the original data type that we would be using. We may set it back to be equal to itself. And again, we're just kind of messing around with this. But you generally wouldn't, like, if someone asks you to do this, you probably wouldn't go out and create a new piece of data to kind of get this done. And you might do something like that. So just wanted to be clear here with the pure functions here that they gave us up here. One, there's nothing in here that takes any outside data. It doesn't take any management of any outside data here. It does create some new data inside of it. It creates some new data inside of it, but it does not manipulate. It does not manipulate anything else there. It creates this empty list to start to collect new things in, and it's basically moving things over from the original list to this new list here. Now, one thing I do want to talk about is that if this was a thing that you were doing, well, no, we're not gonna get there yet. We're gonna get there eventually. So that's what they have here for his example of pure functions, which is true. This is in fact a pure function. It's a simplified version of pure function. We could probably actually, this is probably one of the best ways to do this functionally or not. This is a pretty good paradigm to do it. But it lets you know the original list of numbers is unchanged and we don't reference any other variables outside of the function, so it's pure. So yes. Can be a devil advocate and claim that's not a pure function since JS doesn't make prototypes immutable. So this is Python in particular. But yes, if in terms of JavaScript, absolutely. Yes, JavaScript prototypes and the way that this works, and she calls it out in her. She actually does call it out in here. I think we saw it either up here. Yeah, I think she calls it out right here. You know, object-oriented JS gets tricky. Gets very tricky. That is very true. 150%. I have never written any functional JavaScript code on purpose. To be 100% honest, I've done some stuff because I was a part of like a coding challenge, but never on my own have. And that's kind of one of the reasons. Yes, it is. You are a good call out. First off, a really good call out. For sure, 100% for sure. But again, these are all things that yeah, we'll stop there because I'll go on a tangent. I don't want to go on a tangent about that. A lot of JS talk. Oh, hey, first off, that you called it. You said you were gonna call it out. Go ahead, call it out. Is it on the way? Tell us where to see it at. Tell us where to see it at. Your Dr. JavaScript course, man. Look, hey, let me know. We'll plaster it. We will plaster because we're doing. Actually, we should talk. We should talk, Sharky. You should run the domination stuff. You know, because your boy is honestly one of the most average web developers on the planet. And the only reason we haven't started that yet is because I don't want y'all out here making very average web applications, the most average web applications. Not only am I an average web developer, but I'm also a lazy web developer. So if the box is not aligned properly, but it works, I'm okay with y'all getting a misaligned functional box. I'm okay with that. I'm only fighting. I'm setting a time limit, and I'm gonna work on it until that time limit's up, and then you're getting what I got, okay? And that's not good. That's not good for for user experience. But it's not my forte. You be ready next month? Drop it. I'm telling you, man. We'll let people know. Don't worry. All right. So we went over the pure functions piece, which is nice. But let's see let's jump down a little bit to the things that are a little more complicated. Actually, we went over the immutability a little bit, but let's see what we're talking about here with immutability. So, ever had a bug where you wondered how a variable you set to 25 became none? And I cannot tell you. This is working on a JavaScript Node React project right now, and using Node to do a lot of the automation. It's when I tell people who are DevOps engineers that I'm writing most of our automation in Node, and that's because again we want the developers to be able to if they're having issues or they need to extend something, we want them to be able to do that. So we should work in a common language. Speed, blazing speed isn't a factor for us, and so we don't want to split out the code base. So we do as much as we can in Node for that, and the all of just the asynchronous nature of Node and all that can be very tough, again, because of the state of the application. Knowing where you are, knowing what's happening, a good debugger is nice to help. Like learning how to use the debugger is really nice. And I think when we get to the TDD section, I think I'm actually going to split out a piece of time for us to go specifically over using a debugger, because I do think it's a valuable topic to learn. Even though I console log out stuff until I get frustrated, and then I actually use it again. I'm a lazy dev. I dev the poor way. I also just like exploring again. So like it's like, oh no, I know this. Let me see what's happening here. When I could just hook up to a debugger and have my answer in literally 45 seconds. But I like to make life tough on myself. But immutability. So have you ever had that bug and you wonder how you set something and now all of a sudden it is something else? It is none. It's not the value that you thought. If you thought if that variable was immutable, that error would be thrown where the variable was being changed. And that is the major key. It tells you exactly where it happens at. It doesn't mean it's not going to fail. It means that when it does, you'll know exactly where in the program the changes are happening. And that can be, it's really nice. Yeah, so you can find the root cause pretty easily. And luckily, Python provides some ways to do this because it has some immutable data types. But there also is a whole world of immutable data types that gets added with other functionality, with other packages and things. There's some interesting ways that all these things are actually handled in real functional programming languages. And you might wonder, like, maybe you're not wondering, but if you have a large program and you're writing something functionally, and that program it's creating things, it's creating arrays, and instead of deleting them, instead of using them, it is creating copies and adding to them as the thing goes along because of the way functional programming works. If you have a big application, that means that you can severely affect the speed of the application, and it can use up lots of resources and things because it's creating new things every time a change needs to happen. It's creating new instances of items, of objects, and so that can be problematic. But there are ways that that's handled. I'm not going to dive into those. There's a few different ways that that's handled. Actually, they're pretty clever ways. And again, the languages that are made specifically for functional programming and the packages that exist to help you program functionally will add those things for you as well. So let's take a look at what they have here for their second bit of code for immutability. And talking about immutable stuff here. And actually, let's see what slides she has underneath. She goes straight down to higher order functions. So we'll do this immutability first, and then we'll head down there to see that. And so let's save this. And let's vim immutable. I don't know if it's immutable or immutable. .py. Let's paste it in. And let's see if we can see what happens. This looks like it's pretty straightforward, actually. Mutable collection. The top one is the mutable collection. So the name, we don't even have to give this a comment because the name of the variable tells us everything that we need to know. So this is a collection. This is a list in Python, and it contains, so you haven't seen this before. I don't think you've seen this before, but it contains 3 items. And so actually, just to show you, it contains 3 items. How do we find out how long something is? So just so we can see it in the log, you don't need to do this, but we'll use len, and we'll check the length. We'll check the length of the mutable collection, and some other stuff's going to print out as well, but don't worry about it. Python 3. Oh, is it dot length? Oh no, there's no comma. Whoops. I'll be messing up here. Okay. All right. So first thing it says is length is 3. So we haven't seen that before. I never showed you all this. But in these collections, in this list, you can actually they can actually contain other lists. So you might look at it first and say, hey, there are 4 things in here. There's Tim, there's 10, there's 4, and there's 5. Well, no, this is, these brackets here, this is actually a list. So a list, this list is actually a singular item in this collection. And so I'm actually glad they did that, because now you've seen something brand new. We've never seen this before. So there are only 3 items here. So, 0, number 1, and number 2. And so right here is the immutable collection, the same exact collection of data, but stored in a different data structure, which is this tuple. And then you can see it with the parentheses here. And we can check the type of this if we wanted. All right, so let's see what they're doing next. So we have 1 changeable collection, 1 unchangeable collection. Reading from the data types are essentially the same. So because tuples, although you cannot change them, they're still ordered. So you can use the index to print something out. So the index of 2, remember I said this is 0, 1, and 2. When you print these things out, it looks like you should get 4 and 5 for both of them. So we can access the data in the exact same way. But if you try to change the value, the way that we were going to do it in that for loop earlier is if you try to change the thing in the first spot, so the second item, you try to change it to 15. We can probably do it here, but it says it right at the top, this will fail with the tuple. So let's look at the console log, and I guess we can look at the one right before it. But it goes through, it prints out the same things when we try to access it. But when we try to change what's in it, actually, let's add one more line. So let's actually print mutable collection after we change the item. And this is going to fail, so the program is going to end anyway. And we run it. You can see here that it's print out these things. Then we change the first item, the thing, the 1 index of the mutable item to 15, and it does in fact, we print that out, it does in fact change that underlying thing, but when we try to do it to the tuple, it fails. It gives us the stack trace, this trace back, and it says, hey, you cannot change something in a tuple. So it gives us a much easier, using things like this in functional programming, utilizing tuples really does help when you're trying to go through these things. But that's also just them, they just kind of showed us what tuples are, to be 100% honest. We got the error. Let's see, now an interesting scenario when a tuple may appear to be a mutable object. For instance, if we wanted to change the list in a mutable collection from 4.5 to 4.5.6, you can do the following. And 6 works because the list is, oh, okay. So basically, interesting. This has a lot of stuff packed into it. What they're saying down here is they're saying, although that tuple is immutable, the list that is inside it is not immutable. It's a mutable object. And so what they're showing here is that you can actually append an item to the list that exists inside of that tuple, which is very interesting. And so they're appending it here, and when you print it, it gives you 4, 5, and 6. You can append 6 onto it. That's very interesting, and it works because the list is a mutable object. Let's try to change it back, and you can do what you need to change it back if you want. We don't really need to mess with that right now, I don't think, but that's pretty interesting. Something good to know. It is something that's good to know that lists inside of immutable lists are mutable. Pretty interesting. What's up, Zero Xeon? Welcome. Thank you so much for the host. Good. I appreciate it. Really do. Okay. Let's see here. 2 keywords I missed. Most of Python are const and private. That is fair. Our Python is simplifying code and keeping it small. I don't know. I actually don't know the direction of Python after all the drama. I don't know. I will say though, I've learned to. I used to love that Python use. I used to love Python's syntax with the way it managed white space and using white space to manage scope and structure. But I no longer really like that. And so I actually have a lot of trouble writing Python now because I'm so used to. I do, as much as I hate to say it, I like curly braces now. I really do like curly braces, to to be 100% honest. Kind of sad, actually. Really sad. Never thought I would get here. A Russian doll, it can have smaller units, but each one is a count as one. Yep. Yeah. So each of the items inside of that list, inside of that immutable list, are immutable. Hey Zero Zeon, how are you doing? Okay. Now, perfect timing. 8:10. Let's take a little breather for a second. Any questions so far about what we've gone over? Again, the concepts are important. That's it. Finish your website today. What's your one? Congratulations. That's a big deal, finishing up a website. I have never finished a website in my life. I've always gotten into a good enough state to deploy it and never went back to finish it. But again, I'm not a web dev. Just make it good enough. And in my eyes, a website's never done. But congratulations. That's pretty dope. What'd you build it in? I'm interested to know. Just HTML, CSS, use something fancy, WordPress or something, use Node React. Dope. People always underestimate how much you can do with pure HTML and CSS, and I highly encourage it. The only reason I don't sometimes is because I'm again lazy. And some of the frameworks and things that you can use, again, like I use Hugo. Yeah, I like Go, but I don't use Hugo because it's great, because I think it's great. I use it because I don't want to write a bunch of HTML and CSS. I rather just, modify some markdown and hopefully someone else makes a theme for me. But HTML, CSS, I don't think, I think it's the go-to solution a lot of times nowadays, and no one ever chooses it because there's 1,000,001 frameworks over top of it. That I don't know, but I think it's the way to go. Use Bootstrap for CSS. Hey, whatever works. Bootstrap's nice. Bootstrap's nice. The DevOps talk went well. I can send the URL. It's still going. I think they're still doing the conference right now, so it's live if I send the link. But yes, I can send the link. Let's see. I'm assuming it'll be at the same link that the stuff is at. Yeah, they're still live. It's been going on all day. But I think you can go back right now and see it if you want to see it. A 12-hour stream. That's pretty impressive. They've been streaming for 12 hours. Look, I don't know if I've seen people do some 12-hour streamathons. I don't know if I'm about it, y'all. I don't know if I can do it. That's a long time. When we were doing the Operation Quarantine stuff and we were going like 6 hours, I was like, whew, this is an ordeal. Definitely an ordeal. Maybe we can play some games though. Maybe I do want to do Extra Life this year. I would like to do Extra Life this year. I always wanted to do one. I do it seriously, but I got to get my staying up late stamina up. Like I could do it now. Playing games with people. I think the problem is I had been playing games like alone, and like I would just get sleepy every time I started to play a game. Real sleepy. Never had spent 4 hours and 35 minutes total making it. That's good. Did you track only like total as in start to finish, or total as in hands on keyboard start to finish? Like did you take breaks in there, or is that your logged keyboard time? I'm gonna start logging my keyboard time. I'm almost considering going back to VS Code because there's an application that will do it for you. Maybe they have a Vim one. I need to go check. Oh, that's great. That's really good. Did you design it or did someone else design it? That's always my problem with web dev as well. Design's always, I'm a weak designer and I never want anyone to do it for me. Okay. Now, live split. Yeah, I think, is that what people use? Hey, whatever works. I really need to start logging my time for doing those things. I'm building something right now too. And so maybe I'll see from 100 days of code how much time I'm really spending on these things. See my brain and it'll happen. Hey, well, congratulations. That's pretty great actually. Okay, now to the hard stuff, to the good stuff. We've been focused on this one, and I think her stuff goes into higher order functions at the same time. But it basically says, hey, now functions are first class citizens. They can be inputs and outputs, and this is where this stuff gets confusing. I think it's where it gets pretty confusing. And let's take a look at this, and let's copy and paste it purely so we get some sweet color coding that may help our brains like this. And so this is JavaScript, and I'm gonna call this vim high order .js. Okay, that did not paste how I wanted it to paste at all, or maybe did it? Let me like it's missing something. No, it didn't. It's not. And that goes there. Okay, now this is an interesting function. Oh, this is a very interesting function. Okay, very interesting. Now let's take a look at this. So I kind of want to give this some different names. So they have a function here at the top. She has one called make adjectifier. And so it takes an adjective. So to me, you know, this naming might make sense. I don't know what it does yet, but it takes in one thing. This is a function called make adjectifier. Again, the name doesn't really matter, but it's hard to say. So maybe we'll change the name to make it simpler. And it takes in an adjective. And I know this now may look a little confusing, but this is just a function. And the first thing it does is return something. And so we see two returns here, but we know that a function can only have, once it hits a return, it's done. And I can only have one return, unless it has some type of conditional there, and that's frowned upon. But yeah, you should only have one return. But look at what it's returning. It's returning another function. So this is a function definition here. It's got no names. You know, it's an anonymous function here. It's got no name. But the function itself is not returning a string. It's not returning an integer. You know, it's not returning a variable. It is returning an entire other function. So look at it like this, like separately. And so look at this function. This is its own function. This is a function that takes in a string, and all that function does is it simply returns adjective plus space plus string. It concatenates all of those things. And so we now have a function that takes in something and it returns another function. So this is very interesting. This can be very hard to like follow when you're starting out. And so what they do here is they set up a variable called coolifier. And again, we need to make these words smaller, so it's a little bit easier to follow. But they set up a variable. Cool. We know what a variable is, and it says make adjectifier. And so this function is calling this function right here. And when we call this function, we got to pass in an adjective, and we pass in the word cool. We know that cool is an adjective. You know, somebody's cool, something's cool. Either way, it's descriptive. And so we pass that in. When we do that, the thing that gets returned is not a string. It's not anything like it. It's returning an actual function. And so that means that if running this right here returns a function, and we basically assign that value to the variable coolifier, then now coolifier is a function now. Like now the variable coolifier that we have here is now a function. And so right here, they call coolifier as its own function here, because coolifier is now a function, because make adjectifier returns a function, and they pass in conference, which is a string here. And so when we run this, basically it's going to, everything's going to get kind of passed down, and it's going to say, what is it going to say? It's going to run this first. Cool's going to get passed in. So cool's going to get passed in right here, and it's still going to continue through. Cool is the adjective, so it's going to be cool plus conference. So it's going to be cool conference, right? I think that's what it's going to be. And we'll break that down a little bit more. Invalid token. What did I do? High order adjective plus space. That seems right. Is my spacing wrong? What did it say was wrong? I wasn't seeing that. Invalid use unexpected token. That's fine. Oh, yep. Copy and paste. That's what happens when you copy pasta. Thank you. You are correct. Wrong quotes. Thank you very much for that. Same thing on the cool in the conference. I could do a find and replace, but your boy actually, well, I could do a find and replace, but then I would have to copy pasta those as well. And you know, sometimes it's not worth it. You can do it faster this way. I gotta copy and paste it anyway, then I can do that. And okay, it doesn't give us anything. And why doesn't it give us anything? Because there are no prints here. But if we console.log this, we get something different. There we go. So now we get cool conference. And again, I know that this part can be tough. How do we get cool conference from this? And again, because she used kind of big words here, there's a little bit of inception here, a little bit on what's happening, but it's important to note that before this runs right here, coolifier, after this, let's actually see what happens if we print this. Let's console.log just coolifier, and let's actually call it. Well, we can't call it without calling anything. So no, because then it'll be the same thing we just did. Exact same thing we just did. But coolifier is in fact, it's a function now. Because this function here returns a function, this becomes a function, and you know, it's just what it is. What it is. I don't know if I can make it easier than that, but it can be pretty annoying. If you can console log it, you can see the function, I think. So this without you're saying like this. I don't think you can. Maybe I'm tripping. You can see that it is a function. Yeah, you can say it as a function. Coolifier is now a function. So interesting paradigm here. It's a very interesting paradigm. And so let's see what they say about it in Python over here. Higher order. And so just to be clear, this example does not it shows getting a function as output. It does not show passing in a function as input. So the same way that we could set up a function to where adjective, and again, right, this in this paradigm doesn't make any sense, but where the thing that you're passing in could actually be an entire function. So if that was the case, like it would be like make ejectifier would actually be we would be calling something like our function as one of the paradigms, as one of the inputs, as one of the arguments into the thing that we're trying to do. So that is part of the higher level functions here. Let's what do we pass in here? We passed in, it doesn't really matter. Undo. There we go. Cool. Okay. So that is the JavaScript example that she gave. That's a pretty good example. I think I like that example because it's a little it can be a little bit of a mind meld to like see the double pass down, like, yeah, returns a function, but even when you call that function later, it's still retaining the data from when the function was created. So the function was created on this line. So we've essentially created a new function here. And so if we were to run var another function, so coolifier2, with a different adjective, again, it would create a function that would actually have it would actually end up, the end output will be a little bit different because of the way that we're creating these things. But again, they're all functions. We're using functions to kind of build out the functionality of what we're trying to do. Again, let's see what we got here. I'm gonna write a file 5 times, or log the message 5 times instead of writing 3 different functions. Let's take this first and then read what he's saying here with these higher order. Recall that higher order functions either accept a function as an argument or return a function for further processing. Let's illustrate how simple both can be in Python. Whenever people say, let's see how simple it can be, they're probably lying to us, period. Probably lying. It's probably not that easy. I just was messing me up the other day, Sean. The copying and pasting and weird characters issue is it's a thing. It's for sure a thing. I'm actually mad at myself for not immediately seeing that as a problem, because it happens so often. But yeah, be careful when you're copying and pasting specifically from like blogs and tutorials. I copy and pasted from a slideshow, but specifically from like blog tutorials. Usually things like Stack Overflow and stuff are fine, but 100% it is like it happens way too often. It happens a lot, and that's why I wish sometimes these interpreters, these things would be a little more descriptive. But I understand how hectic that could be, and it was descriptive. It said, hey, I don't know what this thing is. I do not know what this token is. I did not expect it, and I'm confused. But it, to me, it looked like the correct thing, but it in fact was a different Unicode character. Because it looks fancy. Yeah, I mean, that's 100%. That's the reason why they use the little tilty quotes, is because it looks fancier. Yes, you can use the arrow function, and yes, you can use the arrow function for a lot of this. The only reason we haven't covered those yet here. That's the only reason we're not using them, and I don't want to introduce those right now. We're going to introduce them, but we're going to introduce them in the bounds of the second algorithm section that we're running. Again, just not to give you too much in one night, to make sure you can properly do these things. Yep, 100% fancy people, and yeah, fancy people. I'm not fancy, so I don't. Sometimes I just, just write it out to be as verbose as possible. Now, I love arrow functions, to be 100% honest. So we covered scope. I think so. I think we're gonna touch on some of those things. I think we're gonna touch on currying and hoisting and all. I think we're gonna touch on those things throughout the rest of the course. There's not any we touched on scope already, but there's not any like specific things about it. I'll try to be intentional about calling it out. I don't want to call it out here though. I don't want to do that right now. But yeah, it is. It is currying. Yes, it is currying. It's definitely currying, but it is currying. What people are talking about. So there are a number of there are a number of paradigms that exist to talk about the concepts of moving around information and accessing information, and how you can move things through the scopes of a program. So we talked about scoping maybe 2 or 3 classes ago, and maybe I'll try to add some of those things as something to just watch some videos and read through for now. And I think I want to cover a lot of those things, because algorithms too, we are going to cover some of the main, we're going to cover some of the some of the sorting algorithms and stuff, but I don't think that'll necessarily be new concepts. I think it'll more so be the same concepts, but different, like figuring out how to solve them. Is what that really is. Like, you're not learning any new like coding paradigms, to be 100% honest. And so I think I'm going to introduce them there. Partial application. I'm not sure I know what that is. Or maybe I don't know what it is by that name, but I probably don't know what it is. Partial application, JavaScript, or just programming. Oh, is this the, let's see. Maybe I do. Oh, look at that. That's, we are diving into currying now, but no big deal. Difference between partial application and currying. Now we got to learn. Let's learn together right now. And this article better be the best article. It's the first one I found. It's the first one I clicked on. And I'm going to take this as complete truth, as you should. You should take whatever this says as complete truth. So I hope, who wrote this? I hope Mr. Eric Elliott back in 2015. I hope you know what you're talking about, and I hope everything is correct. So let's read this and let's see what we're talking about, because again, this might be something new. This might be a new thing that I learned this week on here. So a lot of people new to functional programming get confused about the difference between partial application and currying. That is us. We are new to functional programming and we do not know the difference. I don't know the difference. Stephen Yeat asked the difference. So we're already on the right track, you know, we're finding out what's going on here. So in fact, until recently, it was rare to see real uses of curry in JavaScript. Okay. Oh, but this is from 2015. Sorry, this is from 2015. Okay. And many of the utility functions calling themselves curry weren't curry functions at all. Great. We're still out on the ropes, but let's read through it. They were partial application functions. Okay. Partial application functions. All right. If you're confused about the difference, yes, I am. The following should clear it up for you. But first, let's get some vocabulary out of the way. Oh, I like your style, Mr. Eric. I want to get some of this vocabulary out of the way. Oh, he starts with the application. The process of applying a function to its arguments in order to produce a return value. Okay. The process of applying a function to its arguments in order to produce a return value. Okay, so it's, just running that function. Partial application, the process of applying a function to some of its arguments. Now this is interesting. It makes sense. The word partial means not to all of it. So we just learned about applying it to all of the arguments in order to produce a return value. The process of applying a function to some of its arguments, just a few. The partially applied function gets returned for later use. So the partially applied function is returned for later use. In other words, a function that takes a function with multiple parameters and returns a function with fewer parameters. Ooh, baby, this is interesting. Okay. I like that he bolded these because this helps. Like, that's where things start to click for me a little bit. I don't know if I understand it yet, but now something means something to me now. So takes a function with multiple parameters and returns a function with fewer parameters. Okay. Partial application fixes one or more arguments inside of the return function, and the return function takes the remaining parameters as arguments in order to complete the function application. Ooh, baby. This sounds very interesting. And what's very funny about this is we came here and he asked us, he said, hey, are you confused about the difference between partial application and currying? And we said, absolutely. And look at the difference in the definitions right here. Look at that. So currying, a function that takes a function with multiple parameters as input and returns a function with exactly one parameter. So that is a curry. And so okay. This is great. I'm still not sure I understand partial applications yet. I'm going to read through it one more time. I see that some things are in the chat. I just want to read through it, see if I truly understand, or if I can see if I can make an example. Process of applying a function to some of its arguments. We already know that. The partially applied function gets returned for later use. Okay, no problem. In other words, a function that takes a function with multiple parameters and returns a function with fewer parameters. Got that. Partial application fixes one or more arguments inside the return function. Okay, one more argument inside the return function. And the return function takes the remaining parameters as, oh baby, I don't have my iPad set up. I don't have my iPad set up. Yes. So is this a partial is what we did? No, but we didn't do the fewer parameters thing. I wonder if that has to be it, but it uses the return oh man, this is very interesting. And now everyone who's watching who's like, hey, we just went level 12. Yeah, we did. we did. This is interesting. This is when things get, confusing. This is when the logic gets tough to wrap your head around, but it's okay. I'm not sure that I know what this is right now. I think that I have a good idea of what this is. I'm not sure of a situation where I would use this at all if I understand it properly, but it is interesting. So I know the difference. So Steven, I know the difference now between them. And I can explain to you what a partial application is, mostly because I'm looking right at a definition that someone else wrote right in front of me. So yeah, no need for me to sit up here and act like that I could give you something better than this. This is pretty interesting. I definitely learned something new. This goes on my what I learned for the week partial application. This counts towards my I'm gonna write this down as in my log for my 100 days of code, because this is interesting. And the thing is, what's wild is I may have done this before, possibly. I doubt it. I doubt it, and not knowing what it was called, but it's very interesting. Keep asking questions like this. I like that. I don't know. I didn't know what this was, and now I do. And now what I'll do is I'll take this information. We'll become pros at it, and what we'll do next time, give this like another year. We'll be doing another intro session. Just throw me the alley-oop, throw me the oop, and say, excuse me, do you know anything about partial application? I'll say, yes, I do. I absolutely do, Steven. I know exactly what partial application is, and I will recite this word for word, and then we will have an example by then as well. And it will be, you make me look good, I'll make you look good, we'll all look great together. I love it. But no, this is pretty dope. I really like this. Let me share this as well. If anyone wants to go over some of this stuff, I really do encourage you to, we said at the beginning, to kind of explore these things that we don't cover completely. Like I said, there is a lot in these slides. There's also a lot in this list that we're not going to cover here. But again, because I want to keep you as focused as possible in this paradigm. But you should go explore everything, because we're actually not going to cover map, reduce, and filter. But I like this slide right here, the don't iterate, use map, reduce, and filter. So I will say, this is the single greatest. You should look into this in your own time, but this is the single greatest image for explaining map reduce. If someone had showed me an image like this when I was trying to understand what map reduce was, I would have had it first. I would have had it immediately. And I like, now I feel like someone needs to create a higher quality official image that works well with this, because it's really nice. And you can see here how we're diving into all these, there's all these concepts, there's all these words, and there's all these things. And this is why programming, why it takes so long to kind of feel like you're great at these things. You don't know what you don't know, and when you run into these things, it can start to feel like, oh man, I thought I was learning a lot. Again, remember that Dunning-Kruger graph we showed? You're learning a lot. You're like, oh, I've got a bunch of tools under my belt. I'm starting to use them to solve problems. I'm good. I really get this stuff. And then people start throwing stuff like this at you, and it's like, where did that come from? Where did that new tool come from? Why do we need this? Realistically, you don't need any. You really don't need any of these things. All of these are underlying. All of these tools have underlying implementations of normal things, but they make your life a lot easier. You would not want to do, a lot, like you could, but map reduce, writing an actual map function is again, is actually not that hard, because of some of the paradigms depending on the language that you're talking about. But this is like, I'm serious. Like I think I saw this. I think I watched her talk for the first time maybe a year and a half ago. Like I think it was right when I was like really diving hard into Go, and I was like, hey, I want to learn more programming concepts. I really want to understand some of these things. And I came across her video, and when I saw this, I was like, I almost got mad at how simple this picture was. And again, I haven't even explained it to you, but I bet if you looked at this for long enough, you could start to break down in your mind that like, oh, like they sliced up the bread, they sliced up the, the cucumber, they sliced up all the different things, and then they reduced them down into sandwiches, from their individual components down into sandwiches. There's filter and things as well. I think she put that in here as well. There's filter, so maybe say, hey, if I want a sandwich that does not have, cucumbers on it or tomatoes, I can filter those things out. She talks about that as well, but it's pretty interesting, and I highly recommend you check that out. She also talks about how these persistent data structures these are some of the other packages that are needed to kind of really help JavaScript be the functional paradigm that people want it to be when they want to do functional programming. So this, these are kind of more advanced topics. I think that there are things that we actually will cover in the intermediate course. I actually think we're going to do an entire week, maybe week and a half of functional problem solving, and kind of paradigms around functional problem solving, as well as object oriented. I think that'll be more of the feel of the second go around of the intermediate courses, kind of taking these things and doing things with them, but also learning more in the process. Oh yeah, 100%. Always have to Google MapReduce syntax. 100%. First off, I'll be honest with you. I have to every syntax for everything. I've written. I'm not even lying to you. I've written thousands of bash scripts, thousands of them. When I tell you, I had to look up, and I don't know why I had to, but the shebang at the top, this slash bin bash. When I tell you, I'm not joking. When I tell you I had an empty bash file saved that just had this at the top that I would have to copy in because I could not remember that syntax. I am terrible at memorizing syntax for every language. And I always look it up, and I'm not even joking. I've written thousands of shell scripts, and every time I'll look up the most simple things, and now that I've been diving into more languages, it's gotten even worse, because the syntax between different things is different, and I do get into the flow. If I actually have to write a fairly large program in JavaScript or something, and I'm sitting there for the 1 or 2 days, 2 or 3 days, working on something, I really get my flow down, and I really start to, remember the syntax and stuff. But then I go and do something with Python, and then I lost all of it. Again, I lost all of the stuff with JavaScript. It's always so interesting. So don't sweat it. If you're always looking up syntax, again, people are like, well, one day, what if you don't have the internet to look it up? What? If you don't have the internet to look it up, then what are you building for? What are you? I don't understand. You are gonna have a method to look it up. I'm sure there are a few caveats to jobs that don't, but if the internet's down, you're going home. Plain and simple. Like I said, there's been times when a piece of a service in AWS went down, and it affected us so much. You're like, hey, everybody, you can't work. Just head on home. We can still do a bunch of stuff, but it's a real blocker. Head on home. If you don't have internet to go look that up, if you don't have access to a browser, then you probably aren't equipped to actually work. So don't sweat that at all. We should have developers when they ask you stuff on stop and you don't know how to answer because you have to look it up. I don't like that people make others. Yeah, I don't either. I'll look it up all the time. I'll happily say, oh, I don't know that. I have no problem telling people I don't know that. Let's go look it up together. Honestly, just like we just did. That's what I do, at least. I'll say, hey, you want to know about partial application? I don't know what that is. Maybe let's go look it up together. And honestly, maybe our shared understanding of different things will help us both understand it better. Maybe we'll read through and I'll say, maybe it's just like this. And you'll say, no, it's like this. I think it's like this. And then we can come to some kind of dope shared understanding and kind of learn off of each other. Don't be afraid to be like, yeah, I gotta look that up. I promise, I'm, now that I have my own company, as I'm hiring, and again, I'm not doing software development right now, but like when I'm hiring for software things, like for me, if it was my company, I like if I feel that it's appropriate to put someone through a coding challenge at all, they're for sure getting like they're getting access to Google. It says, hey, I would really like to work through this problem with you, but I want you to, like, whatever you don't know, I want you to Google it. It's okay, feel comfortable. I am not judging you on the merits. The only thing I will judge you on is I have seen people with very interesting Googling, choice Googling words. And you know, and that's a learned art as well. But I've seen people Google things in very funny ways, and have picked up weird Google habits. I'm sure I have some as well. I might judge you a bit on that, just off of like, I just start doing that, but like not really in your ability to code and find answers. But oh yeah, on the spot, yeah. Nah, like I said, I lead an application development team, a web application development team, and I'm not a web developer. I get questions all the time about things I don't know. And what do? We sit down and we use our knowledge to trace things down. Like I said, what I am really good at, the one thing that I really hang my hat on, is that I'm really good at patterns, and I have a pretty good understanding of how technology works. I have a good understanding of the pieces that exist, and what you can do. I can read code really well as well. Like, whether or not I can write it very well for different languages, a different thing, but I can read, I can follow through, and I'm good at kind of following along with that logic. And I'm usually really good at helping find answers during those times. But look, if you ask me the question, that means you don't know it either. So I have no problem being like, bro, I don't know the answer to this. We don't know it together, and we'll either find out or we'll just never know. No big deal. Okay. Is there anything else we're gonna cover in here? Yeah, let's real quick, let's cover what let's see, does it take a function in any of these? Repeat and actor. I want to see if they take a function in any of these. Yes. Ooh. This one's interesting. Let's look through this one really quick. Hey, Clear Hutch, welcome. What's up, Rizem Tiagci? I'm gonna go with that. What's up, Applesauce Boss? Great name. Love it. Evil Phrase, how you doing? Baki Ralboa, phenomenal. Plop dot pop. I should have said hello earlier to you. Appreciate the follow. Thank you so much. Also, I also want to thank you all for I have not been keeping my eyes on certain metrics. We got over 4,000 followers, and I appreciate that. I was going to do some kind of road to 4,000, but 4,000 popped up super fast. I appreciate the support. Pretty darn dope. I mean, at the beginning of this year, in January, I think we had like right under 1,000, like 970 something, and now we're over 4,000. Pretty dope. I really appreciate you all. You know, I'm glad so many people want to spend their time, you know, reading through articles, seeing if we can figure out what partial application is, which again, I'm hoping that I understand. And maybe what I'll try to do is, this is a good one. This is a topic bigger than a lot of the other things that I've learned. This is probably the most complicated topics that I've learned from the stream, from a question asked, especially. The video that I had been recording with that stuff, is I was kind of going through and explaining the things that I learned and what they were. So it's just a hodgepodge of random information and kind of showing that stuff. Maybe I'll try to not use this and see if I can come up with a good example of this, so that I can, you know, truly know that I understand it. Functional program as a rabbit hole. You want to learn Haskell in no time? Yeah, I do want to learn Haskell, to be honest. A series on YouTube. Yeah, 100%. You 100% link it. 100% link that because I want to see it as well. Again, it may put some things in. It's probably going to put a lot of things into context for me. Even though I'm learning Rust right now. You know, I actually started yesterday, diving in a little bit, just learning the extra basics. I went through Rust by example, same thing like Go by example. I went through Rust by example, which is nice. Again, because I have a solid understanding, at least on a lot of the base level programming concepts, a lot of this was easy to hop in and go with. There's some stuff in here that I don't know about, but again, it gave me a place of reference to start to write things down, and to start to understand the different things in Rust. I'm going to check out some of those things as well. Raid incoming. Ooh, Raid, welcome to the channel. Hold on. Welcome. I appreciate the raid. Rocket Sage, welcome to Mastermind Academy. Tonight we are learning about some functional programming where we're, welcome everyone from the Sage Raid. Let me let you get through a little bit of those ads, but hello Sage Raid. First off, let me get you on the shout out, /SO exclamation point. Let's see if I can spell today. Nope. Let's see, Sage. Where'd your name go? I can't even see it anymore. Sage, was it underscore? Oh, Sage, Rocket Sage. See, Rock. First off, phenomenal name. Hello. Thank you very much. All of the Sage Raiders, welcome. It's good to have you. Come on in. Prop your feet up, get comfortable. I mean, even though we are right now, we're just shooting the poop with each other. We're having a little fun. Tonight we talked about functional programming a little bit. Earlier this week we dove into object-oriented programming. What we are doing right now is we are in the middle of we're finishing up week 6 right now of a boot camp called deCoded. We are learning the basics of software development and software engineering. There will be 3 parts of this. There will be 3 8-week courses. This is the beginners course. There will be an intermediate and advanced course. And again, tonight we're just getting our feet wet with functional programming. We're still in here doing a little bit, having a little bit of fun, not going too deep, but we're having some good conversation. We just learned about about partial application and its relationship and difference to currying. So that was interesting. I did not know what partial application was familiar with currying. So I now know. Maybe I need to put together an example. That's how I know when is when I can put together a really good example. But how's everyone doing? Thank you everyone for the follows. Dane Yankee, Weneg, let's go too fast. Wenegiska, welcome. Predator, how you doing? Gabe Aisha, welcome. Thank you so much for the big raid. What were you all doing over on the the Rocket Sage channel? What was going on tonight? How was the stream? I hope it was great. Hope you're doing some dope things. I'll definitely have to check you out. Sage is a geologist and part of the Knowledge Fellowship community for educational streams. Phenomenal. Super phenomenal. I don't know. Because you're here and we're in the science and tech section of this as well. Maybe let's expand, or let's share what we know about geology. Everything I may say may be wrong, but I do know that there's a rock called igneous, I think, and I know that magma comes from a volcano, and lava is also a rock as well. What else do I know? I know that moss grows on a direction of a tree, maybe the south side, and I think that I took physical science in college, and and part of that physical science course was geology, but I don't remember that much from it. Gonna be 100% honest with you. I tried. That was I did my best there. So that's pretty dope. That's actually really cool. One of the things that I'm actually planning on doing when I introduce myself a little bit. My name is Aaron. I'm a DevOps engineer and technical lead at a software company. So I generally do things with cloud computing, software automation. And so we teach things surrounding the software development lifecycle, not just programming, but again, cloud computing as well. Cloud computing, Linux things, all kinds of this stuff, automation around that. But one of the things I want to do when I do still work for a company, I'm actually going to be leaving that company to start my own business full time this year. And one of the things that I watch a lot of videos on how people live their lives and stuff. And one of the things that I want to do is actually spend a significant amount of time carved out to also learn about other things in the world that aren't related to exactly what I'm doing, but to get a more full grasp of things. So I've been actually looking at some of the things that I want to learn. And there's a lot of science topics that I'm pretty interested in learning. So pretty dope. I'm glad you all are here. Very happy to make your acquaintance. I'll for sure check you out and see what's going on over there. To binge videos about ALUs all today. That's pretty dope. That's pretty dope. The masses with global coral reefs. Okay. Oh, global coral reef death. Oh, that's sad. That is sad. Typical world topics make everyone feel all warm and fuzzy. That's fair. That's fair. I want to say, I feel like I did a project on coral reefs, but I don't remember. Partial functions are one of my favorite things. Well, Larry, they're not my favorite thing because I don't know that much about it. I just learned about them now. So yeah. Do you respond to Discord DMs? Sometimes. I have, you know what? Can you guys, which screen can you all see? If you could see how many here, watch this. Check this out. I do respond to Discord DMs, but I get lost in all the messages that I get, to be 100% honest with you. So definitely shoot it over. Shoot it over. Maybe I'll do my best. But check this. I want to show you guys this. Can you see? I do this and then I turn this capture card off. Okay, so now you can see this desktop. Check this out. First, I want to show you my Slack. Look at my Slack. Look at all of these unread. Just look at it. Look at all the stuff. And most of these Slacks are important. So that's just Slack. And then Discord is also a whole different level of things. Actually, it doesn't look bad right now. I get a lot of stuff from live coders. But yeah, there's a lot of things. It's hard to, I'm gonna be honest with you, it's hard for me to keep up sometimes. I'm working on it. I'm working on a method to to manage this. Again, it does get tough when, I'll catch up every now and then there'll be a single day where I'll be swamped at work, and then I'll get back and I'll be overwhelmed by the amount of things there, and I just don't mess with it. So yeah. But cool, Rocket Sage, thank you so much for the raid tonight. Pretty dope. We raid people at the end of every single stream. We need to start venturing out into other topics. We usually try to keep it in the same paradigm so people can go learn, but I actually think that's pretty exciting, pretty dope. 0 inbox, then 0 chat box, never 0. Come on. What kind of animals are y'all? How do you get to 0? You don't even want to see my email. You don't. Oh man. So yeah, yes. The problem is my intentions are good. I think that's the issue, that like my intentions, the reason it gets like that is because I actually do go read the stuff. Like I don't just click the button and just let everything go to red. Like I go, when I go in to read it, like I read the stuff and I respond to it, but like it's just such a daunting process to find some time to do it. It really, really is. But yeah, I really appreciate you coming through. I really appreciate the raid. Thank you, Rocket Sage. We'll definitely check you out for sure. I'm really interested in learning about some of that geology, and picking up some new skills. It's pretty dope. I text you on Twitter and you can backtrack to the Knowledge Fellowship. Oh, dope. 100%. I'll check that out. Yeah, so Twitter is the one place I do pretty consistently respond to things because it's much less overwhelming, to be honest. I change emails to have no unread emails. Hey, that's fair. But again, thank you so much, Sage. Okay. Honestly, that's it tonight. I'll give you a lot of your time back. I would check these out. Again, I wanted to introduce you to these paradigms. We are not going to, actually, you know what we'll do? Since there is some extra time, what we'll do is let's actually go If you need to go tonight. That's the end of the concept. So tangible takeaway from tonight. The tangible takeaway from tonight was simply that we learned a new paradigm for programming. We learned object-oriented programming earlier in the week. We now learned about a new paradigm called functional programming that is, instead of centered around objects, it's now centered around functions. And those functions being the main thing to take in data and get out data that we need to get to our end state. We learned about pure functions. So we learned about when that functional programming tries to keep the functionality and the data separate. We learned about pure functions a little bit. That's one of the main concepts. And these are functions that always will give you the same output depending on whatever the input is. It'll be consistent output if the input is consistent. And these functions only do the things that achieve the goal that you're trying to achieve. They don't use any outside data. They do not use any data from outside of the scope of that function, and they do not change anything as well. We also learned another concept of immutability in these functions or in functional programming, that instead of using these variables in the way that we normally do, when we create these data items, we don't change them. If we do need to make modifications, we create completely new entities and assign values there so that we can follow what's going on. It makes it a little bit easier. It makes it a lot easier actually to debug and know what's going on, because we've removed a state from the program. There's not a weird state that we have to follow as we go through the logic of the program. And the last thing we learned about as a part of that was higher order functions. And functions being first-class citizens, where basically you could use functions as both input and output to other functions, and so you could operate with them the same way that you've been operating with other data types, data structures as well. So we also learned a lot of little cool things in there as we were kind of going through those. We did some examples. I highly encourage you to at least watch the video that I posted that goes along with these slides. I think she's a really good teacher, and I think she talks about these things in a great way that you could understand them conceptually. You'll still have to practice to kind of really get in and get it, but I think she'll cover a lot of the tough concepts to cover to kind of understand what's going on there. But also, I like that there's a lot of code here for you to see and for you to copy if you want to. There's these lambda expressions. I think there's some arrow function stuff in here too. So there's both of these things dive deeper than we dove tonight. It is okay to go that far. Again, we're in the 100 days of code. Dip your toes into it. It's okay if you dive in for a little bit, you spend some time and you're like, it's not clicking. It's okay. You can always find some other resources to try to learn it. Maybe something is maybe you need to watch a couple videos or something, or maybe it's not time for you to learn this thing yet. Maybe take in what you knew, backtrack a little bit, maybe while you're trying to learn something, you'll see that there's 4 or 5 other things that have been referenced that you're not sure about, that you're not confident about. Take your time. Not a big deal. It takes a while to get here. We're still learning stuff constantly. So check those things out. But maybe what we can do real quick, just to help everybody out with some of the 100 days of code stuff, and just to start practicing again a little bit more of what we know. Y'all want to try out a exorcism problem real quick? We did a simple one last time. You guys want to go through one of them real fast together? That might want to do. Now that we know classes, we skipped over one of them in particular because we had classes. Did we do hamming? I think hamming is what we did. We did calculate the distance between cells. We did that one already. Which one were we looking at? Isogram, high scores. I think high scores was interesting. I think this one gave us class. Maybe we can try. How much time do we have left? 9:03. It took us longer than I thought last time to do that. Maybe we can do raindrops, even though we've already done what's it called, FizzBuzz. That might be a good one as well. I'll be lurking. Appreciate it. Yeah, early night. Again, everyone, get on out of here. Go relax if you want. Congratulations on finishing out week 6. We've gotten through a lot. The final final 2 weeks, there's gonna be some interesting stuff. We're gonna do some practice. We're gonna have a panel. We're gonna learn about errors. We're gonna learn about test-driven development as well. So some cool stuff to kind of round out the core of our knowledge, and then you'll have some time in between this one and the next one to practice, and we'll talk about the next steps and when the next things are going to be, what we're going to do in between for you to practice. There's gonna be some pretty cool stuff in between here and there, and again, we're building out some pretty serious things in the background, so I will try to keep everyone abreast to the situation that we're doing there. Actually, you know what? It's 100 days of code. I think that everyone should go off and try some of these things themselves. You know, now I'm giving you the time, so use this last half an hour to go ahead and do that on your own. You know, to dive into whatever it is that you want to dive into. Time's it's a precious resource nowadays, so I'm glad we're getting to do this. What I'm gonna go do is I'm gonna go spend my time doing my hour of code, working on the platform that I'm working on. But everyone, keep an eye out. I'm gonna try to tweet out. I think I can finish tonight. I'm making it so that yes, the videos will go on YouTube. People will watch them on YouTube, but people have expressed the need to want to download the videos as well. You can download it from YouTube, but you got to go through some third-party app. I'm setting up a videos.mastermind.io where they can be grabbed from an S3 bucket as soon as the stream is over. Hopefully, I'll finish that up tonight, and a link will go out on Twitter. But if not, whenever it gets out, we'll do that. But yeah, go relax, have some fun. You know, talk to each other in chat. Let me know what y'all are doing in Slack or Discord. And I'll see you all next week. That's it. Yeah, that's it. I'll see you all next week. Thank you very much. Sorry everyone who came over with Rocket Sage. You know, you guys came over right at the end. I appreciate you coming through. I'm definitely going to be coming over to learn with you all as well. So cool. Who are we rating this evening? Also, I'm actually glad we're ending a little bit early as well. I'm being a little bit selfish as well. I finally took a little bit of time off of work, so I'm off Friday and I'm off Monday. So I'm gonna get a nice, you know, a little span to kind of not really worry about work. It's been a while. It's been a while since we really did that. So it's gonna be it's time, just gonna relax, I'm hoping to build some cool things and just have some fun with little to no pressure. It's gonna feel so good, so good. Okay, let's see. Help me set up test PA. Let's see. We got a fish tank here. Let's see. Study. This person's studying. I don't want to mess up their studying. What is USMLE prep? We got to look that up real quick. USMLE. What is that? USMLE. Step 1. Oh, medical licensing. Let's go say hello. Let's give some encouragement, since we're all gonna go off and do our own things, and we're probably not gonna stick around for amazingly long. Let's go hype someone up, because they're learning just like we're learning, and then and go have a little bit of fun. Let's see. This person. Auditory. I'm sorry, we're not going here. This is an ASMR channel. Kind of weird. It's not weird. It's not weird. I take that back. ASMR is weird to me. Like, it's like, I don't know. It feels like everyone's being all like secretive, and like it's gonna be weird. TKF has an inventor at large live, Laboratory 24. That's where we're going. I'll take it, Uncle Bill Druin. We are going right over there. Are they live right now? Let's see. Laboratory. Is it 424? Oh yeah. Let's see. Cool. Let's head over. We're heading over right now, over to Laboratory 424. Say what's up. Raid 424. All right, everyone. Have a great night. Enjoy your weekend. Spend a little time doing what you love, getting a little bit better. Relax. Have some fun. You know, and I'll see you all next week. We'll start week 7. You only have 2 weeks left. You've made it this far. Only 2 weeks left. Again, pat yourself on the back. I'm having a great time. I hope you're having a great time as well. And yeah, I'll see you all next week. Let's hit the raid. I should have hit the raid button 10 seconds ago, because now I have nothing to say for exactly 7 seconds. So we're gonna sit here in silence. Okay. 3, 2, 1. Now let's go. Peace. I'll see everybody later.